It's unclear why Russia has recently begun to promote its plans to establish a base on the moon or send humans to Mars. But Russia has made it clear that they have plans to try to get there before the US and Elon Musk, as they are now testing a nuclear spaceship to beat. But why? It's possible that witnessing an American company like SpaceX design and build spectacular rockets has brought back memories for Russia of the space race. There could be a financial incentive, as possessing the technology to travel to Mars would be pretty spectacular and attract a lot of financial support. Perhaps it's just pride. Russia still remembers how America beat the Soviet Union to the moon, and having a private American firm reach Mars first is totally another level. Whatever the reason, Russia wants to go to Mars and is planning to deploy cutting-edge technology to propel its rockets to the Red Planet. They want to rely on nuclear energy. Welcome to Futured. Today we'll share about how Russia is testing a nuclear spaceship to beat United States and Elon Musk. Before we do, subscribe to our channel to get updated with everything on future technology, Elon Musk, or SpaceX. Let's get started. As the private space race heats up in the United States, other nations' space programs aren't planning to sit out either. One of the most well-known of these national space programs is Roscosmos, the Russian state space agency, which now has a nuclear-powered deep space rocket that could change rocket propulsion forever. This is all part of Roscosmos's proposal to use a nuclear energy module dubbed the Zeus to travel from the moon to Jupiter. Let's take a look at the Roscosmos Zeus program and how it could revolutionize future space travel. The world first learned about Russia's Zeus initiative in May, when Alexander BLISCHENKO, the executive director for long-term programs in science at Roscosmos, unveiled the program's parameters at the New Knowledge Forum in Moscow. When speaking about the Zeus program, BLISCHENKO stated that the mission will last 15 months when combined with the Russian Academy of Sciences. According to Roscosmos, which has already signed a contract with a private Russian engineering company, they are now making calculations about the flight's ballistics and payload. The Arsenal Design Bureau will begin development on the proposed nuclear-powered spacecraft, also known as TEM, or Transport into Energy Module. The deal is worth 4.7 billion rubles. BLISCHENKO stated the intended mission first, a nuclear-powered spaceship will deliver a spacecraft to the moon. After delivering the spacecraft to Luna, the nuclear-powered rocket will head towards Venus and utilize its gravity to sling towards Jupiter satellites. This ambitious plan is set to be implemented in 2030. Only until the spacecraft has reached a 600 or 800 kilometer orbit, far enough away from the atmosphere to avoid natural disintegration and re-entry, would the nuclear reactor on the vehicle be turned on. According to some estimates, the Russian TEM would have a payload of 20 to 30 tons. The ANGARA 5M or the ANGARA 5V rockets would be required to carry this mass into orbit. So why is all of this relevant for the future of deep space travel? Nuclear-powered propulsion has a number of advantages over conventional chemical rockets. But to fully appreciate those advantages, one must first understand what those advantages are. Let's take a look at how traditional chemical rockets work. Chemical rockets take advantage of the fact that every object has an equal but opposite reaction. Chemical rockets use rocket propellants and oxidizers to create a combustion process. The thrust of the rocket comes from ejecting mass from the rear rocket as it burns in the chamber. The force from the ejecting mass is directed downwards, and the rocket is pushed towards the sky. Instead of using the chemical energy of propellants to power a rocket, a nuclear thermal rocket employs a working fluid like hydrogen to give the energy. The hydrogen is heated in the rocket's nuclear reactor before being forced to expand via a rocket nozzle to create propulsion, similar to a chemical rocket. This thrust allows the rocket to roar into the air. A nuclear reactor on a nuclear thermal rocket works in the same way that a nuclear reactor in a power plant does. First, heat energy is generated from the fission reaction, and then the propellant liquid hydrogen is pumped through the reactor core, heating it up. The heated hydrogen is then expanded and accelerated out of the thrust nozzle of the rocket, creating thrust. The electronic propulsion system heats and accelerates ionized gas using heat generated by a nuclear reactor. This ionized plasma is employed to provide thrust for the rocket as a high-speed ejecting mass. These engines are frequently referred to as ion or plasma engines. This is the path that Roscosmos Transport Energy Module program is going. According to the Arsenal Design Bureau, they conducted various studies and developed early designs of such a spacecraft between 2016 and 2018. The mock-up prototypes comprise a truss carrier section and a propulsion unit module made for future spacecraft between 2016 and 2018. According to information released by the Arsenal Design Bureau, the 10 will be powered by a nuclear reactor, but it will also have a system of radiators to generate excess heat energy as a power source. This energy will be used to meet the power needs of spacecraft, such as powering onboard equipment. One of the key advantages of adopting nuclear thermal propulsion is that a nuclear reaction provides more energy per molecule than any chemical reaction, making nuclear-powered rockets more efficient right out of the box. Scientists predict that nuclear-powered engines can reduce the time it takes to get to Mars by 20 to 25%. To put this in perspective, it presently takes chemical rockets 8 to 9 months to travel to Mars. This means humans will spend less time locked inside of a spacecraft on their way to Mars. Another benefit of employing nuclear thermal rockets is that because they are more efficient, less weight is taken up by fuel. Nuclear thermal rockets will also save money because less fuel is required to complete the same route. Using nuclear energy to power rockets is not a novel notion. In fact, scientists like Stanislaw ULAM and Friedrich de Hoffmann began working on ideas to use nuclear energy to launch vehicles into space as early as 1944. In 1946, the United States Army Air Forces recognized the benefits of using nuclear propulsion to power their fighter aircraft. As a result, the Aircraft Nuclear Propulsion Program and later the Nuclear Energy for the Propulsion of Aircraft was started to develop a nuclear-powered rocket engine. It was later discovered that utilizing a low molecular weight molecule, it was conceivable to build and operate a reactor engine, but due to technological restrictions at the time, it was impossible to produce and operate such an engine in 1961. The Atomic Commission and NASA started the Nuclear Engine for Rocket Vehicle Application Program, or NERVA for short, which designed and developed 20 reactors to be used in rockets. The program was later disbanded in 1973 due to budget cuts, and it wasn't until 2018 that NASA received funding of about $125 million to begin developing a modern nuclear propulsion rocket with advancements in material engineering. This time it looks more promising. Russia has a long history of experimenting with nuclear rocket propulsions, dating back to initiatives like Roscosmos. Their plans to employ nuclear energy in space date back to the Soviet era, when the USSR put over 33 military reconnaissance satellites powered by nuclear reactors into orbit between 1969 and 1988. These were thermoelectric nuclear power sources that would supply power to the satellite's equipment. At the same time as NASA was working on the NERVA program, the USSR was constructing a prototype of nuclear thermal rockets. However, the USSR project was shut down in 1986. Under the presidency of Dmitry Medvedev, Moscow revived its nuclear rocket ambitions in 1998. From 2012 to 2018, the initiative to create a nuclear rocket cost Russia $233.24 million. The money was split between Roscosmos, Russia's space agency, and Rosatom, Russia's nuclear energy agency. It's understandable that Russia wants to be one of the first countries to launch a nuclear-powered rocket into space. With his 500 kilowatts nuclear reactor at the heart of his Zeus program, Russia hopes to revolutionize rocket propulsion. The future of rocket propulsion may very well be nuclear propulsion. For now, all we can do is wait and see how Russia's nuclear space experiment goes. So who do you think is going to win the space race? Do you think Russia is going to reclaim its once lost glory in the space arena? That's all for now. Don't forget to subscribe to our channel to get updated with everything on future technology, Elon Musk, or SpaceX. Thank you for watching.